have joined the session now.
We can start, no issues.
Okay. So
I have to give the introduction, then I can switch over.
Right. So I'd like to introduce the speaker of the current session to the participants. He is Mr. Anuj Saxena. He is founder and CEO at Institute de Informatica, Dehradun. He has 28 years of industrial experience and has demonstrated history of working in the research industry. A motivational speaker, soft skill expert, and a writer. He has trained over 1,100 professionals, many research papers, theses, and patents guided or published. Mr. Anuj is skilled in cognitive analytics, deep learning, machine learning, data analytics, NLP, IoT, network security, and whatnot under the roof of computer science. He is a research paper reviewer at many international journals and conferences of repute and has to his credit 3 SAP HANA certifications and is a certified ethical hacker also. So welcome to you, sir. Welcome to the session. It's our pleasure to listen to you.
Yeah.
Yeah, over to you, sir.
Right. Thank you. Okay, so all will be muted, I believe. So if anything is there, we can put it in the chat and we can discuss. Okay, so we are going to discuss about the graph databases again, as we discussed earlier also, and how the graph databases can be useful and how they can be interpreted, right? So what we are going to do is first we have to collect some data. So how we have to collect the data from the net, I'll just share that. Few links are there. We'll be sharing it.
Yeah, Anuj sir.
Yeah.
I'd like to interrupt a bit. If you could speak for 5 minutes, why graph databases? Because the many of the participants may be new to this FTP. Yeah. So the title of the session and why are we doing it?
I'll show it practically and why.
Yeah, practically that
is
true. It is a hands-on session. We are so happy.
No, that's okay. I'll just show you. Just 2 minutes. Give me 2 minutes, okay? I'll show you. They will be able to understand why graph database and what is graph database.
Right? Fine. Please go on.
Yeah. They will be able to understand. Absolutely no issues. Share first. I hope it is visible now.
Yeah, it has come.
Yeah. Okay, let me first tell you the background of graph databases. Basically, they're unstructured graphs, or you can say our database, which is based on unstructured data. When we say unstructured data, it means that it may be in a very raw form, like a text file, right? A PDF file, a doc file, it can be anything, right? So we have to create something, some meaningful information from there, and we have to extract some information from there, like you have FTP and all, you have the relationship and all, and in a SQL, MySQL, like SQL or Oracle, you have a very structured data, you have a table there, right? But in graph databases, we don't have any tables. Okay, we just have relationships, we have entities, and we have relationships. Okay, now suppose we have something like this one. Indian law, you know, is huge, and the cases are pending like anything, right? If I want to put it in a SQL, I can do that, but it will take me ages to do it, and interpretation will also take a lot of time. Now, what is the advantage of a graph database? Is it is much faster than your SQL, right? Any SQL you're using, it is much faster than that, and you can create as you want, the way you want, right? You can create the graphs, or you can say the nodes. I would call them nodes. Node is the data, okay? So it is, you imagine a tree, okay? You imagine a tree, just pluck it off, and invert it. So you have the root and the branches, just like your Linux. In Linux also, if you know, and if you have worked on Linux, it is also like that only. The root is at the top, and then you have the branches. Same way, a graph database would be like that only. You have a main node, and then you have the graphs. One minute. Anyway, so that is the introduction part. I think if you have any queries, you can fire the queries later on. But let me show it practically how I am going to do it, and what it is, and what is the advantage, right? And since it is a huge database, it takes a lot of time, and that is why the other system is still trying to cope up with the data I have put in that into. So, but it will be fine soon, but it takes time. So I'll be cutting the data short because I cannot have the entire data. Let me come to the legal cases. As I said, we have huge number of legal cases in India, and we have so many acts, and the laws are there. Like we have IPC and all, CRPC, IPC, CPC. We have so many, right? And in that, let me show you. This is a lawyer reference. This is a very interesting site, and you get all the information from there. And, let me see. If I put IPC here, what I get? I will be getting something like this. Indian Penal Code and all, everything is there. But the sections, let me come back to the home page and you'll see what all we have, the main acts we have. Now the challenge is to put them into some meaningful information. We should have some meaningful information from there. Yes, bare acts. These are the main bare acts. We call them bare acts. Okay. Must be wondering why I've taken this one, but I'll come to something more meaningful also. Right. This was taken actually because our Prime Minister once asked the IT industry to design something which can help the nation to solve the pending cases issue. So when a lawyer goes to a court, he actually takes some references from the previous judgments. And these are the judgments, and we have to put the judgments basically. These days, everything is digitized, but it is not in a meaningful data. Right? What we have is a PDF file or a text file or a doc file, which actually is a raw data. Right? Let me show you what I mean. These are the things in the IPC, abetment, criminal conspiracy, and all, so many. Now, if I click on abetment, this is instigating someone. Okay. Then we have sections also. See, so many sections are there, all belonging to one abetment. From 110 to we have 120. Yeah, so many sections are there. So a lawyer would be able to understand that. Yeah, that is what I'll. But yeah, but actually, it is not required as such for now. We are just concerned about the data and what we are going to do with it. That is more meaningful for us. Yeah, because if I am going to go into this, then see, This will be huge, right? So let's do it. I have echo from somewhere. Oh, let me stop this video. I have logged in from two places. That's why it is giving me the audio from everywhere. Okay. Mute this as system is working, then I can work on this. Okay. So there's so many, and let me come back to the home page and see the BRAC. And we also know that we have so many courts, High Court, Supreme Court, right? And all of them have judgments also. Right? Now, to get the judgments, we can go to the Supreme Court site, and from there we can actually take the data. Let me open that for you and show you from there I can take the data and how it is going to help me. Okay. Let me switch off this video. Share. Okay. Share. The site is name.test.gov.in. Ah, okay, I hope you can see the thing.
Yes, it is visible. Please unmute yourself, sir.
Okay. You can hear me now?
Yes, very well.
Okay. I actually muted myself from both the sides. Okay. Now, see what I was saying was we can have the case number, diary number, judgment date, if you know the judgment date, judge, name of the judge, parties, act wise, if you want to find the act wise, or if you know the constituent bench, you can find that also with this one. Let me get it in here and let me go back here. Just an example to show you how the data can be retrieved. 19 into 20. That has to be filled. Okay. See, this is what we get. The data. Now, and this is the PDF here I get. It will come. Takes a little time, but it will. The Supreme Court site is actually very busy these days, but today should be a holiday. We should not get up now. Yeah, the judgment has come. Okay. Now the thing is, here we can do two ways. We have two ways rather to get the data from there. Either I download the site, the page PDF file, you can say, or I can go directly. But going directly is always a problem. Okay? Because we do not have the permissions. Had it been Java, I can actually bypass that. I can give the certificate and I can get access to the site and the PDF file, and I can download that. But in Python, I tried so many things, but actually downloading it and getting the data is more feasible in this case rather than the part. Okay. So I'll be downloading that and then downloading also through the code only. So I'll be sharing the code once I have it with me. I have the code with me. So you have seen this. Let me get the code. I'll explain the code and then I'll run it also.
Sir, you are not audible in case if you are speaking something.
No, I was not speaking. I was just trying to get the code. Okay. So this is the site from where I was telling to download the video. Okay. So I put the path here. I need URL library. This is required. I hope I'm audible now.
Yeah, you're audible.
Okay. So you can see that the path is there, and I have written a function to download the file, URL the file name, and I'm saving it as a case1.txt file or PDF file. Yeah, it is a PDF file. I'm saving it as a PDF file, case1.pdf. Now comes this part. This PDF number actually is the best way to read a PDF file in Python. There are many other modules available, but PDF Plumber is the best one to read the PDF files and everything. But what I get is a binary data. Okay, and I need the text forms, but this is the only way I could get the exact data set. Okay, so what I have to do is I have to open it, the PDF file. I have to find the length. I have to just read the page. It's very simple. I can simply do that. Okay. Now let me see. I can run this code quickly. We have data. I'll just run the code. Okay. Jupyter for that or Colab, I can use Colab for that. You see if I can run Colab. It can run Colab. No, there would be no issues of such. Okay. Colab is open. Okay. The only issue is with the neo4j. I cannot draw neo4j here. Colab. Not draw my graphs. Otherwise, it can be done. If it is visible, let me know. If I'm audible, let me know. Audible?
Audible, we can see it.
Okay. So I'm okay. I'm putting the code here. I'm using Jupyter. The lab is also open, but I would like to run it here. Now I'm going to be running this. Please save the file. Run the code. Yeah, it has run the code. And let me show you where the file has gone. You can see case1.pdf. I can open it. See this PDF. We have read the PDF, right? Now comes the other part. I'll give you one link. This is a PDF file. You can read the PDF and then you can convert it. It's not a big deal. If it is not sent, let's just here. This is Indian Kanun, find Indian Kanun. And there is a let me get the link again. It's the same thing. It is not a research. This is the size, right? Visible. Or should I enlarge it?
Yeah, we can read it.
Okay. Yeah, I increase that. Right? So this is what we have. You can see. So this I'm reading directly from the web, and I can put the code to read it and then convert it to a text. And then share this. This will not be here you are. So for this I have some modules here. And this is the site. I'll be using the response to get the content from the site. Beautiful soap is also used to remove some lexicals, some extra words. We have RE also. I'm not sure. Are you guys familiar with Python, or should I explain that command also?
Sir, sorry to interrupt. I think you have two IDs and in another ID, can you please mute it, sir? Actually, it is echoing.
Sir, you just switch off the speaker. Voice बंद कर दीजिए दूसरे वाले PC की.
कर दी मैंने.
Fine, sir. Thank you.
It is off. So what I was saying is, are you familiar with Python?
Yes, sir. Most of the participants are familiar.
Okay. Fine. Then it's okay. Okay. So okay. So what I'm going to do is I'm going to run this. Collab, when you run for the first time, it takes little time. See, the document is there. Show you. It has read the document. And what we have done is we have taken only the keywords which has frequency more than 8. Okay. Frequency more than 8 only I have retained, otherwise I have not taken anything else. And for this I've used item getter. And that is very powerful. Now this is prosecution. Okay, purpose, case. These are important keywords of legal things. Otherwise, there are useless words also, which are actually of no use. I can see that the is there 100 times repeated. We can remove it. Absolutely no issues, but it is not required to remove because we will be using legal dictionary to take care of this. So legal dictionary, what the legal dictionary is going to do is it will just remove what is not required and retain only the legal words. Fine. I'll show you how it is going to work. Going to create a legal dictionary. This I will just start. This is done now. Will to read the legal word and create this also. Okay. have text files here, legal words dot text and legal guide dot text. What I did was we have some PDF files. I converted them to text file first. Okay, because I just wanted the words. So I just said it, and if I can show you. Legal guide. This is legal guide. The big file is a small file. Okay. See, there are a lot of text here. Explanation is there. This one is a bigger one. Okay. And if you remember IPC first one, abatement is there, so you can find the word there also. Okay. And there's one more where we have only the words. This is arrest, Bandani. Okay. So what I did is I read those and files and created a list here. Legal words. So that I can use that for filtering the text. When I get the text and I get useless text also, text which is not required, so I can remove it. I will be sharing the code later on for the text files also. For the notebook is also there. We'll be sharing it definitely. Yeah. But if you're not able to see, I can enlarge the. This is this is better, I think. Right? All right. So what I've done is read it, run it, and what I did was, see, this is the testing which I did. Like we won't be having the base words, but dictionary has the base words. Like in English, what the base word is like without ed, ing now, right? Like arresting is not there, arrest will be there. Arrested won't be there, but arrest is there. Okay, so we cannot put all the verb forms there. So what I did is I did stemming. Okay, and for that I use NLTK stemmer. Total stemmer is used, and word tokenizer I have not used, but it is still there. And I run the code. I'm just trying to check whether arrest is there or arresting is there or not. It will show me if it finds that it is there. It solves my purpose. So when I read a text file, what I have to do is I just have to run if word in legal words and stem it and words. That's it. And I'll just right. So let's see what we get. It's time to run. Just waiting for the thing to work. Meanwhile, let me see what we have. This we have done now. Yeah. taking a lot of time. But actually, the legal word is a big file, so little time to generate list. neo4j. Open another one. Meanwhile, I'll just work on the still working. Taking more time than it normally takes. It's not a big file. When I say big file, it means 1 TB plus. Not that big. It is the big file. Also. But that doesn't take time. I've already done that, so done that. So see it here. I already ran it, so you can see that it will be detected and we will get found here. This is the code I have put actually. Okay, so we create a list and then we find it and stem it and find it. What I can do is when I use any of the text file or any PDF file while filtering, I can put this. I can use this one. This code is good enough to retain only the relevant legal words. Others will be.
Sir?
Yeah.
So please check if the volume is 0 for the another PC.
No, 100%.
Sir, one PC, make it 0. For one of the PCs, make the volume as 0 for the speaker.
For the speaker, yeah. For the speaker is on. Huh?
Sir, we have to make the speaker off for one PC.
That is on.
Because whatever I am also speaking, it is coming from 2 PCs out.
Now what?
Yeah, I hope it is fine now. Let us see.
I have muted everything. Even the video also. On one system, I have muted everything. Okay.
Yeah,
I
please
think
go.
it has worked. Okay. So it has worked here also. And this is what we did. Now, I can this file. Close the files up or what so that just stop the sharing, otherwise it just pops up. And just closing the files I don't need. Okay. Now we come to the graph database. I'll be sharing that with you. The programs. neo4j. Okay. Now it is visible. I can select on the other system also. That is why I'm using to. Now what you have to do is first you have to choose the folder where you want to store your graph database. And the last folder has to be default.gdp. Okay. What I have to do is I have to choose and then I have to start. I've already the default will always be there. The default folder is always there when you create neo4j. Otherwise, you can always create your own folder wherever you want to store the graph database, and then there you can put the things. Right? Fine. Show you where I have the files. In 4J sometimes. Okay. It has come. Okay. So the default folder is there, but I want somewhere else. So what I can do is I can go to the folder, and you have to keep in mind that if you press enter, it will give you an error. Okay. This is document. There is one more.
Sir, I have a doubt. Can I ask?
Yeah, definitely.
Sir, in this neo4j, which database are we importing? The one which we created by crawling the code website using the beautiful soup. So, are we importing that database or some other database in
No,
neo4j?
we are taking from the web media.
From which web, sir? The one which we crawled or the different one?
No. The one I showed you. The PDF files na, from the Supreme Court site. From the Supreme Court site, we have a PDF document na, and then I
Yes.
told you the other one also. From there, the data was taken. See, yeah. Tell me.
So, sir, we dumped the entire PDF and then we extracted the useful keywords from the entire PDF.
No, what I did was I because the PDF reading directly was an issue. So what I did is I saved it on my system and then I extracted only the keywords.
Yes.
Right.
And then
that was retained, and then we can create a CSV file if you want, or we can do it on the fly directly.
right.
Both are there. And if it is a text file or if it is just a content, then I can do it directly also.
Right, right, sir. Right, sir. Thank you, sir.
File folder, the code base is there. There is one more and created. This was already there. Create another. That's not an issue. Create another. Done. I have to create a default .gdp graph database. This is required, otherwise things don't. Give it as okay. So I've chosen the graph file and I'll be putting the data there, creating the text graph from a document file. Okay, it has come, so I can start the browser. The browser has to start, otherwise you cannot actually type your codes. Won't work. To give the password, neo4j, and the password is also new. Okay, let me share this with you first. So initially the password and the username and password is same, neo4j, and then you can change your password to the one you want. Change the password. Okay. That's open and it will be empty. Okay. So what I'm doing is, first of all, I'm creating a graph from a pieces. taking the legal also, just want to show you something. Let's do this. Create a new. I've already typed the thing. Choose the name. And so those who are not familiar, so let me tell you a few things here. We need Pi to Neo to connect to a graph database. Visible now? I think it is visible.
It is visible.
So earlier it was little small, no? So the code was not. Those who have already done, they would know. But this one is. Okay, from there we need graph, node, and relationship modules we need. And I've used string punctuations, item data, and for cleaning the data. And I'm using a doc file, docx file, or docx file. This is interesting. Why I wanted to tell you. Otherwise, I would have taken the text directly. Since it is already a clean text and I already have the text with me. But creating a graph database from a text file is interesting. It has the headers, and you have to read the headers. Then you have to read the content. Okay, so thesis.docx. I used a thesis and I converted to a graph. Now thesis.docx is already uploaded here in the Jupyter notebook. Okay, the base we have loaded. I have put some remove list and regular expressions, and I'm removing that which is not required. Then I'm using the doc to read the paragraph style. And if it is a title, see, I'll be putting it as the header. Title as the header of the graph. And then the nodes will come. Reading the heading. I'm reading only heading one. Headings are the. And on purpose, I made it heading 1, 2, 3. You have in Word now, you can make heading 1, 2, 3 default. Now, I'll run it and then explain it to you because it will take time. So I'll explain the code while it is running. Okay. I'll run the code. Will take little time. This is okay. Now, from where we have to understand, this is what I'm reading, heading, the data, relationship, the heading and the subheading. This is what we are doing with the cleaning part, regular expression null. Then we are splitting. Then we are removing the punctuations, plotting the words, getting the words only, and here the keywords are there. Finally, I get the keywords. And this is how we create a node. Not creating is this. First, we declare a node. Yeah, any variable can be used. I've used P2. P2 is equal to node keywords. I've used keyword as the label, and name is equal to word. You can create any label. But since I'm using keywords, I have put keyword there. Okay. Now we have to set the relationship, and must have seen earlier at the top that we read the title. So title was at the head node, and I have to connect that with the head node. This your keyword. Okay. And the subheadings. The heading has to be with the title, and the keywords are with the subheadings and the headings. Okay. So relationship has to be set. Should not be errors. Package. Oh. Thesis.docx is not installed. Let me put it here. Is not there. Oh, stop it for a minute. Let me install, upload that. Docx file is there. Thesis of docx is there. I have to choose. I'll share it. Yeah. I'll show you the file. This is the doc file I've used. I'm uploading it on Jupyter Notebook. You can see the headers and all. Abstract is there. Header is there. Headers. This is a 27-page thesis, not big one. I've taken a proper thesis. Obviously, I will not be putting the graphs and all. Information on the whole system. Share. Yeah. It's giving me a bit. Wait. Can I share my screen? There's some issue with the WebEx, the other system. Trying to resolve it. I've run the code. It is taking little time to create the graph, but it is working fine. Show you once it is done. Mhm. Did I share this? To be sure. Explain the code in the command run the top. The compiler. Okay. So this is the code, but if I'm using compiler, won't run here. Giving this a pure already community. You don't know. Okay. So 1 minute. So this is the header, and this is what we created. Header is the title. P0 is equal to node header name node header. Node header is what we have got. And I think it is abstract or whatever the title is. Then we run this and we create here, we get the heading and then we get T1. That means one node is created title. Then we have another heading node and then we will have the keywords. Okay. I have the graph with me, but I cannot show it because this WebEx is giving some issue. System is working, but somehow WebEx doesn't want to work. When process is I show you. Show you like this. Charts. I'll show you. Like this. There. It is generated on the WebEx. Let me see. The graph has come, but it is not. The WebEx is not running. Launch it again. System is not running. WebEx does not want to run. Okay. Let me see. I'll show you the graph later, and let me show you. Let me share the code first for the legal cases. Graphs are there. I can show you once the system, the WebEx works. Let me get the data. Okay. This one is legal. Okay, so here you are. We are working with the. I'm just showing you the code first of your legal cases. First, what I did was I created a root node. It has Indian law as P0. Then we have IPC, CRPC. These are the different acts we have: CRPC, EBD, CPC, Constitution of India, Hindu Marriage Act, Juvenile Justice, Indian Divorce, and so on. There are many. I've used only a few of them, just 12 of them. There are more. And now I have to create. If I were using a Spider or something else, I don't have to give graph.create P1, P2, P3, P4 and separately. I can actually use them at once. And then I can do that. But I can use like this: P1 dot P2 dot comma P3 and so on. But this does not support. So Jupyter Notebook requires that you should be using it separately. Volume is off. Okay. Okay. And then we have to create a relationship. Whenever we create a node, we have to create a relationship. You have to create a relationship and set the relationship of these nodes with your root node. So root is P0. So P1 with P0, P2 with P0, everything will be with the P0 node. Okay. Again, you have to create the relationship. So graph.create. This is what we have to do. And this graph has come from here. This object is created. and you can get it from here. Okay. Now, this IPC, as I showed you, had so many abetments.
Sir, have you shared some screen?
No, I will be sharing.
Okay, right.
1 minute. I think I have not shared. I will just talk in 1 minute. 1 minute, 1 minute. I was actually using the other one now. 1 minute. Yes, now it is there. Yeah. Thank you. I thought I have shared because it was already shared. Then I stopped. Anyway, now you can see. I can explain it again.
Yeah.
This is the handle I have to create for the graph. Then a root node P0. It can be any variable. This is just a variable. You can give anything. Then you have to give a label. This is a label. And then you have to give a name, whichever name you want to give, or you can give any keyword. Okay, this is what I have given name. You can give anything, whatever the data is. But this is something which is static, which is to be created. So I created this one. Now we have different apps here, and they have been numbered P1 to P12. Right? What I did is I given ID also name and ID here. Name is IPC, CRPC, EVD and all, and ID is 1, 2, 3, 4, 5, 6, 7, 8, 9 till 12. And then I have to create that graph.create P1, P2, P3 and P12. What I was saying is if I were using Spider or something else, I could have given like this in one go, so on. But Jupyter's notebook somehow does not support this syntax. It takes one at a time. So I have to create graph, not create P1, P2, P3, P4, and so on, P12. Then I have to create a relationship between the root and the node. Okay. So my root was P0. So P1 is to be with P0. Everything has to go to P0. And then again, I have to create the relationships like this only. Don't like to write in the codes, but you don't have a choice sometimes. Okay. Then we have the IPC. I created a list of IPCs. This is from the site, directly from the site I've taken. These are actually the basic structures, and then you can put the data. Right? This is the basic structure, and then the data has to go. So we have created this one. And I've used a loop to do it because otherwise giving the commands again and again takes a lot of time. I'll have to create the node M1, and you can see this. There may be a question that I've used P1, P2, P3, P4, and so on for every node, but here I'm using only M1, and there are around 12 IPCs, right? But it doesn't work. It doesn't matter. Whatever you give, it is just a variable, so it can be anything. But when we access, it does make a difference. So we have a way out to do that. Now, what I did, node type of the law. IPC, I have already saved. ID I have given as I, and under, they all come under IPC. Right? They're all IPC apps. Then create, and then relationship. Now go with P1 with M1. Okay? P0, P1, P1, M1. And then again, create the relationship. share with you. This is the code. And now how we are going to, and the data also has to be there now. Putting the data also. I can stop the share. And the code has already run. You can see this is the previous one. This is what we created from the thesis. Okay, this is thesis data. Now I can use this star to see, and header, as you can see, towards a systematic approach to big data benchmarking. Just a bit. I hope you can see it now. Sometimes, if the details are not visible, you can just put your mouse there and you can see the details. If I double click on this, nodes will pop up, right? Abstract. The data has come. There may be duplicates also because I have not cleared it. Okay. And have the keywords. You can see that they are not connected at all. Only header is connected. Because when we go to relationship, then only you can have the connectivity. Right? In headings, subheadings, everything. This is MD5. If it is not connected with anything, then we won't get to it. All the interlinking you can see. How the data is interlinked. This is subject and object relationship. You can see the predicate. Here we have something meaningful like it is a part of knows, known, likes, friends, whatever I can want to give, which is meaningful can be given. Okay. And property keys, the names and the stars we have used. Stars are just numbers, relationships. These are the names here which have been given, and you can see the data. You can see the.
And I have a question.
Yeah.
Sir, what could be the purpose of such a visualization? Are we trying to find different communities in, among the entities, or what?
The point is when we this is not like a visualization. This is the creation of the graph database only. So visualization is part of it, but it is, you can see the cipher query which is executed, right? Like if I go to header, okay. If I click, so what you get in return, you can get the data also. I'll show you. This is in neo4j. You can get only the graphs. You want to get the data, you can get the data also. This is where you get the data. Okay. But this is only for visualization, and what purpose it solves. Actually, when you break something, into meaningful forms, meaningful data, then it is easier to extract the information, right? Suppose I want to search a keyword, like suppose I want to check flag. I have the words here, okay, and when I go through it, and I want another two graphs are there, and I want to compare those two graphs. I can easily see what is matching, what is not matching. Word by word, it can match, right? It can match one word by word, and it can give you the exact thing. Like even a flag and plagiarism, even if you're using Turnitin, it may skip, but in this case, it is very difficult to skip, and it will show you the links also, and it will show you. I'll show you the link using the legal cases, and also the similarity. You can calculate the similarity. You can do anything what you want to do with the database, right? Visualization is a part of it, but you can extract the information. Here, in this case, only the keywords are there. But in the case of legal words, we have put the data also. I'll show you that. Okay.
Okay, sir.
Is it clear or any other doubt?
In fact, sir, probably I missed something I do not know, but I remember that we extracted the important keywords from the PDF, from the data.
That is it. That is it.
And then we I mean, from where are we getting the relationship among the entities, like say HKW and then the other relationships, I mean, being shown here. From where are we getting these relationships?
Let me show you the code. Let me show you the code. Okay. That is there in the code actually. Okay. Relationships actually, they are not automatic. We have to create it. Okay. Now see. What we did here is we got the style and we got the title of the document. Okay.
Yes.
Then we created a node header variable, and then we created the node. That is the header node. You can see the title there. Header. See, towards a systematic approach to big data benchmark. This is created once you run that code. Okay.
Sir.
Title. Now, it is actually hanging in the air. It has no value unless it is related with something. Now comes the heading. Find the heading. We create a node with a heading, whatever the text of the heading is, this one. And then we create the graph, the node. The DOLA has to be created. Now you have two roundabouts without any relationship, right? That is what was bothering you, right? Now, I have to create a relationship here. I know it is a subheading, so I have put it as subheading. Relationship of P1 with P0. That is all the subheadings will go to heading, the title, right? We have heading and headings. Header we have, and the headings we have. And now I create the relationship. Now further, if I go down and break the words, the text, this is what. All the nodes will be created like this with the keyword. And then we have the graph created, then relationship now will be between P2 and P1. P0 P1 and P1 P2. You can say like this. They put it the other way around. They put P2 first and then P2. Similarly here also. Otherwise they will not be connected. They will still be hanging in the air.
So do we have to know all the relationship among all the entities in advance?
No.
I mean, beforehand.
No, not at all. Sometimes we take it from the text itself. You can take it from the text also, these entities, actually entities, so you can get any, because you don't know, even I don't know what is coming in the text. Only I have the thesis, so I know the text is there. Okay, and I can read the text and I can get the information. But even I don't know when I'm running the code, I don't know, okay, from where or what the text is coming, what headers are coming. I don't know. And what relationship I should be setting. But I know that it is a subheader of a title, a header of a title, or a subheader of a title. So I just put the thing like this. Like keywords, that is the label, and is no, I have put is no, that is, it is a part of it. It can be anything. Whatever makes sense, you can put. Okay. Whatever makes sense to you, whatever you think is more meaningful, you can put it like this. And because when we run it, you can see subheading off. If I click, I get the subheadings.
Right.
This is a cipher, and you can run the cipher query just like that, graph.run, and this in the codes in Python, and it will come. You can run directly. I'll show you. The other example I'll show. Is it clear?
Right.
Now it
Sir.
helps?
Thank you. Yes, sir. Yes.
Thank you. It's okay. But if it is clear, then it's okay. I can clear it later on also. Fine. This is just something actually which was very challenging for a document file to be converted into a graph database, docx file. So I created, and I just wanted to share this. I will share the code also, because reading a header from a document file and the titles and the other parts was a little challenging. It took me some time to understand how the doc file works with Python. With Java, I could have done it much lesser time, but I'm not using Java these days. So I actually started with Java only with graph database, and it is more flexible. I find it more flexible, but anyway, doesn't matter. So I'll have to now stop this one. I have to launch it again. I'll show you more meaningful things. The graph which is already created, I can show you, because it was taking a lot of time. See, I told you if I press enter, then it will give you a nice did it myself. Is there a go back again? Double click is okay, but if you press enter, it gives you. For this, I have already shown the code, what we did. It is actually clubbing all together, and it is very time consuming, and we don't have, we cannot actually do it in 2 hours. It takes at least 1 or 2 days to create the graph if the entire data is there. But it will give you a fair idea how to create a graph database and how meaningful it can be from the queries. I'll be firing some queries from here, and you can see that. Okay. Just starting the graph, new project. And can you see now?
Yes, sir.
I'll show you what I'll do. I'll run the code again, but it takes a lot of time to do it. Let's not do it. First, let's see the queries and all, and then we'll do it later. Let me go to the first actor. This is the header. Indian law. Let's see the Indian law. Is already there. You can see the different IPCs, CPCs. This is already there. Relationship is act of is this depends under. I'll run it again also, but for now, just see the graphs which is under. This is abatement. Okay, so all the cases of abatement, you can see the file number. Is it visible? Yeah. At the bottom, IPC ID 105 acquitted 0. 0 is not acquitted and 1 is acquitted. I put it to 0 and 1. Name is abatement and file number is there. So if I have the file number, what I can do is I can go to the Supreme Court site. I just put the file number and I can get the data. These are not the original file numbers because I could not share those. That was, I don't know whether it was legal to share the numbers or not, although it is online. So I just created some file numbers. Okay. So these are not original, but yes, you can see file numbers are there. The cases. A lot of time, only abatement you can see, otherwise others are also there. I'll run it and acquitted. Let's see the data. File number, ID, name, entity names. Star is only relationship under what? You can see the property keys and the meaning and the data it has. You can get the file number from here as. But then you won't know here which it belongs to. But if you want to extract, you can use the cipher query and you can extract it also. So you can put it the cipher directly, or you can just put it like this. Now let me show you. The queries we have generated. I'll share the code later on, but for now, since I stopped it, so it is giving me error. I had to stop it because it was giving me a lot of time, taking a lot of time rather. So this is what we created. I shared already this with you guys. This is what we have. So if you want to run a cipher query, I just told you that you just have to put it like this. If I put data with it, the data will come. Okay. So match is to find. This is active, return, a name, a ID. There are only two things with this, name and ID. So, and I put the limit to 12 because there were only 12 records. Otherwise, you can just remove the limit, it will repeat. That because there are two graphs there created. So there will be 24 results. Anyway. So see, Hindu Marriage Act and all, everything is there. This is the same thing. Now come to this one. Only small differences are there, type and relationship. Label you can give any, or you can add your label also. I'll show you how to add the label. Now you can use a loop db.labels. db.labels, actually we have only one label with every node, like at and all. These are the labels. We match the label, return number of counts, count, and then we'll type. You can see these are the relationships we have. Same way you can give the labels and the relationship. They are same actually because we have given only one. So you will see that there only is act of is offender of. Although we have more now. If I run it, I can get more queries. Let it be. Then run it. Now suppose what is the use? Now comes this graph is there. Okay. Now when we have the graph and when we have a new case, what we do is we clear the contents, we clear everything, we get the keywords, right? Once we get the keyword, we can search it in the graph whether it exists or not and where it exists, right? Like suppose there is a case which is going on and Supreme Court wants to refer to the cases which have been or are having the similar thing, keywords you can say, a similar case, like suppose it is a murder case where the thing has gone to even the Supreme Court. Like we have many murder cases where the cases have gone to Supreme Court, and in Indian judicial system, it starts with the lower bench, then goes to the high court, and then it goes to the Supreme Court. So it is a long process. And to cut short, we should have the history. And Supreme Court has the history of the cases. That's why I've taken the Supreme Court cases, right? Now, once the new case comes, a judge has to do what he has to do is, or not the judge, the system, what the system will do, take the FIR, okay, FIR filed by the police, and get the keywords and see what all cases were there related to it and what judgment was given. Although I have not extracted the entire thing, but this is how what I can do. Like I chose the keyword abatement. This is just an example because the graph is big. So if I have the query, it will take a lot of time. It may not take time. Match p type where p name is name and return p name dot as case. Now this query result, I can put it result is graph query name, and then I can put it in a list and then put the list out. Although I have not extracted anything else, only name has been extracted, but we can extract anything. Like return p name, instead of that, I can use the ID or the file number. Okay, that will be more meaningful. Instead of p name, once p is there, p is a type of label. In this label, if you find abatement, all the cases related with that will be stored here in this case. Okay, return p dot name as the case, and then query can extract graph.run query. The result will be here. This is just creating the query, and this is running the query. If you want to run a cipher query, what you have to do is graph.run command is there, and then you have to give a label also. So label is already there, name is equal to name. Then give results in get. This is what return as case. P name as case आया, so this has to be case. Right? It can be file number also, and that will be more meaningful because then I can simply put the file number and get the details. This is how many times it has come. It's just showing me that. Now, if I want to get the entire details, you can see I can use match n type. N type is all the nodes. Okay, किसका type का? You can see one minute. Let me share the type, clause, IPC, app. Any of that, this label can be given. You can see node labels. Okay, any of the label can be given, and you can get the data. So you can get it from relationship also, but you can get it like this also. All right. Now you can see this is one way. The other one is you can use matching node.match graph, result node.match actor, name IPC. This is generated like all the data in type. You can print result also and see what is there. Now, one label is already there. Like in type, we already have a label. I want to add one more label. So I can put one more label as AB. I can use this label and then extract the data using. Since I ran it later on, I was not running on this place. I couldn't find this label. I was running at some other place. Now, suppose this is created once. Once it is created, but when the new case will come, it has to be added, right? And since I was using abetment only, so I put the data in abetment only. What I can do is I can put it in abetment, then I can create a node, get the data. This one. I'll move my cursor to abetment node using this graph.nodes.match type name is equal to keyword dot first. Dot first is first appearance, first time wherever it comes. Okay. Then I create a new node, the new data. This is the new node which is created now. I put convicted, yes, I can put 0 1. Okay. Under whatever you want to give, we can put name of the accused. Hari is there. Graph.create B relationship you can create, and then you can create the relationship of P1 with A and A with B. P1 has to be there. Otherwise, what happens? It will just hang in the air. If you don't create the relationship properly, then it will make no sense. If I can see Hari is there or not. It was in IPC. Happens under. I'll have to animate it. I changed a lot of things, so I'm not sure. But it will run. Amendment is there, IPC case is there, type is there, so it should run. Hence under is okay, this case off is okay, should run. It's run. So let's see if Mr. Hari is there. IPC should be there, but I have actually a lot of nodes here. Yeah, see, in abetment, ID 0 under IPC, Hari is added. You can see IPC and law is related. IPC has a lot of other cases now, as abetment and all. So this is the main graph. This is related with the subgraph IPC. You can see abandonment, and then this is the accused. This is the case actually, which has come. Up until now, it was only just creating the data, but this is the case which has come. But other cases are also there. We have created other cases also like this, but we have not put the name, just the file number. You can see file number, abandonment, and repeated. It's all abandonment only. So it was not required to put the abandonment, but I could have put the name of the accused. I could have made it. Right? So this is how you can create a new node, or you can query and get the information using the above commands. You can get all the data. The visualization part is okay, but the data part is here because this is a list you can access directly. Okay, you can convert it. See, this is what you can access dictionary here. There is a Python dictionary which is created, so you can access it directly also. Just give the ID, location or location, and you can get the information. But the more main part is to actually search for particular keywords, and that keyword searching you can do it using this. There are few things which actually the problem with Python and with the other things is that when it upgrades like neo4j also, then the previous queries or the previous commands don't work. This is what is working. It took me some time to figure out how it is going to work in the new versions. Otherwise, in Java, you don't have any issues. You can run directly. You can run the commands. You have the options to traverse the graph. You have the algorithms to traverse the graph. Even we use PSO to traverse the graph. You have options. I'll be sharing the code with you. If you have any queries, you can fire. Notebook, I will be sharing. That is not an issue. Any questions, sir? Guys, any questions? Now, this graph will be very big graph. What one can do is, as an assignment, what you can do is you can create the graph and you can create a subgraph from it. When we create a subgraph, the queries are very fast because suppose if I take only IPC, even in that IPC, the cases will be in lakhs. But if I take only abetment, the cases will be lesser. So what you have to do is from the main graph, you can create the subgraphs. And the commands are already there. I've shown you the commands, and you run it from the main graph, you create one graph, and then from there you can divide it into subgraphs. And it takes actually time to generate these graphs only. It is only during the generation time that it takes time. Otherwise, it doesn't. The queries are very, very fast, and microseconds you can get the results. It doesn't take time to query. And as you divide into subgraphs, the queries are faster, very fast. Okay. So it can be more beneficial than your MySQL or any other graph database if you divide into subgraphs. Okay. Because the graph, suppose if I have over a 1 TB data, it will take me a lot of time to create it. And then queries will be little slow, not very slow, because graph database queries are very fast. They are not very slow, right? So they will be fast enough to get you the relevant information. Okay. So I'll be sharing the codes with ma'am. The notebook I will be sharing and the code also. And just clean out the things which is not there. I've already actually created the text file so that can be shared. So that will not take much time for me to share. Everything is there, and just have to put it in the notebook. And you can use any thesis. Okay, I've created a thesis. You can create any thesis, or I can give the thesis. That is not an issue. It's already awarded, so. But we cannot share all the data of students and the codes. So codes have to be here. Okay, guys, any other questions? If you have any question, any queries, any doubts, please let me know.
Sir, what about the scalability of neo4j? Does it scale well for the large data?
Yeah. Any amount of data can be there. Any amount of data. There is no limit to data.
All right.
Now I'll share that. I'll share the PDF also and the converted text also. I'll share everything. I've created a folder where I have put everything there. I can share that. Absolutely no issues. Yes, ma'am. Good. Any queries? No. I can't hear you. Ma'am, I can't hear you. Muted up. I muted up.
I was muted. Okay.
As I was.
Thank you, sir. I hope the participants will take back home many things from this talk. And I will share with the participants whatever content you will pass on to me. I'll share it with them as soon as possible.
Yeah. I'll do that, because without that it is of no use.
Yeah, so that they could practice also and grow it the way they want.
Yeah, you can grow it, because I've just given the basic inputs, because it takes a lot of time. I was creating the graph, and with the data I had, but it took a lot of time, so I dropped the idea of doing that.
Yeah, hopefully they have got a fair idea of how to use NoSQL databases, specifically Neo4j. What is it used for?
You can create from NoSQL, from SQL also to NoSQL. Anything. You can create from anywhere. I'll be sharing, and I'll be there if they need me. I'll be there.
Yeah, true.
If they have any projects or anything, I'll be there to help them. Or if they have any problem with this also, I'll be there.
If you could drop your email ID in the chat box also, that would be fine.
I'll just do it. This is my ID.
So guys, this is the email ID of Mr. Anuj Saxena, and the phone number also, so you could connect to him directly as well.
Anytime.
Yeah, thank you, sir. Thank you so much for being here.
Welcome.
Yeah, guys, so we'll collect again tomorrow in the morning, 9:30 sharp.
And happy.
Yes, sir. Happy to everybody.
Yeah.
Yeah. Okay. See you. Bye-bye.
Bye, ma'am.